All right, section 16.4, we're now going to be dealing with the radian measures and trig functions. So how do we deal with all of our 6 trig functions when our angles are in radians as opposed to degrees? Okay, so the first thing that we're going to talk about actually is how the radian angle measurement relates to the arc length and the radius of the circle. So if you recall from the previous section that the angle in radians is equal to the arc length divided by the radius. So we had this formula, we dealt with it in the previous section. So it was the arc length of the radius, but if we cross multiplied, we get the arc length is equal to the theta, or the angle measure, times the radius. Well, this can be useful if we know what the angle measure is and we know what the radius is. We can figure out what the arc length is. So it's another formula to calculate arc length. So this is the second formula that you guys are going to be using, which is that S is equal to theta times R. And the only thing that you have to be conscious of is that in order to use this formula, your theta, the angle that they give you, has to be in radians. Whether the radians are in pi form or they're in decimal form, that doesn't matter as long as it's not degrees. Okay, because if it's in degrees, it's going to give you the wrong answer. Okay, so let's do a couple of examples here. First one, they give us that theta is 4 pi over 3 radians, and our radius is 100 units. So let's just plug these into our formula over here, because we're supposed to find the arc length. So S is equal to your angle times your radians. You simplify this out, and depending on what form they ask you to leave it in, if you leave it in pi form, it's 400 pi over 3. And if it's in decimal form, that's going to be 418.9 radians. Okay, so the second example here, you have to be aware of that theta is given to you as 175 degrees. Well, because it's in degrees, we need to convert it first into radians. So from the last section, we learned that the conversion factor, you're going to multiply this by pi over 180. And we simplify, we get 35 pi over 36. So after we figure out what that is, now we can plug our angle into our formula with the radius length and calculate it out. So if they ask you to leave it in pi form, it's 175 pi over 9. And as radians, it's only 61.1 radians as a decimal. Okay, so that's the formula there. The other thing that you're going to need to do is learn how to use your calculator in radian form. So on your calculator, in the previous unit, we had to make sure that it was always in degrees. So hopefully you found your button on your calculator that allows you to switch between degrees and radians. And so switch to radians so that in the window it has a little RAD or the letter R. Okay? And now when you type in your angle, remember this is an angle, and it looks different because we're used to looking at this as, say, the cosine of, I don't know, 38 degrees, and you would plug that in and you would get a decimal for an answer, right? Well, now we have to think of this decimal here as the actual angle measure in radians. So the cosine of 0.2187 radians, just plug in the decimal and hit cosine, and you should get 0.9762. So check it out. If you didn't get that decimal, then you don't have it set in radians correctly, or you hit the wrong button. Okay, so let's try the next one, the cosecant of 1.8446. So the cosecant is the same as 1 over sine. So this is really 1 over the sine of 1.8446. And so when you calculate that out, you should get 1.0387. Okay, so down here, these two examples, they give us our radians, our angle measure, in pi form instead of in decimal form. So what we're going to do is we're going to convert this pi over 3 into a decimal by taking 3.14159, or hit your pi button, and divide it by 3. So you get the cosine of 1.047. You get this really long decimal. Just keep that in your calculator and then hit the cosine, and you should get 2.5. Now that came out really nice. So think about what this radian measurement is in degrees. Okay, so if we plugged in 180 for pi, 180 divided by 3 is 60. So the cosine of 60 degrees, if you recall from that big table that we did, came out to be 1/2. Okay, let's try this one. The cotangent of 3 pi over 2. So once again, let's convert this into a decimal, and the cotangent is 1 over tangent. So we're doing 1 over the tangent of 4.712 blah, blah, blah. Okay, so when we do that, when we plug in the tangent of this number, what happens? We get an error message. That means that whatever we plugged in when we tried to take the tangent of it, it didn't work. So we got to figure out what's going on here. We got 1 over an error. Well, if you're getting an error, that means that you had some fraction that you divided by 0, right? So if we're dividing by 0, it's like 1 over 1 divided by 0. Well, that's just the reciprocal of this fraction, 1 over 0, which would then be 0 over 1. So we get 0. So there you go. Why would this happen? What's going on here? Well, if we convert this into degrees by replacing pi with 180, then this is really the cotangent of 270 degrees. And so now you can think about that as a quadrantal angle down there at the negative y-axis, and hopefully you either have those memorized or you understand your triangles. Okay, there you have it. And we will talk again soon. Have a good one.